Binyagan mo na yan eh.
I-discuss natin yung yung example ng Chemostat, yung wastewater treatment. Ano specific example ng Chemostat? Yung wastewater treatment. So let me share the PowerPoint. So move na lang tong ano no yung mga ano tumayo ba't ba nakahiga siya? Anyway, basta galawin niyo na lang yung camera para mabasa niyo yung PowerPoint. Okay, so what are chemostats? Chemostats are essentially a CSTR or a chemical reactor, chemo, containing microorganism at steady state, stats, no? So yun yung origin ng ano niya, nung word na chemostats, no? A steady state. Tapos yung chemo is a chemical reactor. So the number of microorganism in the feed is generally 0. So you have here an illustration of a CSTR. Tandaan niyo pa naman ng CSTR sa ano no? Sa chemical reaction engineering. You just have a vessel, tapos you have a stirrer. Tapos generally you have an input stream right here. Tapos nag-overflow siya. So parang ito yung output stream natin, ano? So generally pag ano, so it involves microorganism, ano? So kung minsan yung microorganism mismo yung product, and then kung minsan meron din tayong product na pinoproduce. Okay? So generally, syempre pag merong SO is the substrate. So pag merong pagkain yung microorganism, generally dadami sila. So that's why kung kahit na initially 0 yung microorganism, tapos pero meron din naman dito, syempre meron din yung initially may microorganism din dito sa loob ng ng reactor. So pag pinakain mo yung mga microorganism, kahit wala kang ini-input na microorganism, dadami sila. So yung mga anak ng microorganism, no, generally, yun yung wini-withdraw natin. Lumalabas siya dun sa system. And then syempre yung pagkain nila, halimbawa ito glucose o kaya sucrose, syempre after paglabas, mababa na siya. So generally mas mababa tong S kaysa dun sa S sample. No? Tapos generally steady state kasi nga chemostat. So yung kung ano yung flow rate na pumapasok yung F is the flow rate, ano? Halimbawa ml per hour, liters per hour, yun din yung lumalabas, generally equal yung F. Okay? So okay. So let's let's recall the
He's gonna pull, he's gonna show the body pull, the body can't slip, can't roll. Go to that body, make him come up, and then bring it back.
Okay. So ito So reviewin lang muna natin yung mga concepts. I think I have already introduced the specific growth rate, So the specific growth rate, we earlier defined this as the reciprocal of the residence time, itong 1 over tau. With the unit of per unit time, So and also this is also kasi 'di ba ang residence time is volume divided by the flow rate, no? So pag specific growth rate, this is equals to flow rate divided by the total volume. Okay. So sa sa chemostat, we have another term for specific growth rate. So we're going to show that a specific growth rate is the same as dilution rate. So actually, ang definition ng dilution rate from the word dilution, ibig sabihin pag dinidilute mo, dinadagdagan mo siya ng ng liquid, ng water, parang ganun, ang dagdagan mo. So it's also defined as yung, this is the reactor with a volume B. So kung ano yung dinadagdag nyo divided by the volume of the reactor is also defined as the dilution rate. So soon, sa sunod na slide, we're going to show na we're going to derive the equation that we're going to use to solve the problem. So bale, in this particular slide, so i-recall nyo lang, di ba, dinefine na naman natin na yung specific growth rate is the reciprocal of the residence time before. Yun lang naman yan. Okay. So basically, this is the Monod equation. Itong So this is the Monod equation, This one. This is the Monod equation. So as you can see, this is very similar to your Michaelis-Menten equation. Di ba ang nangyari lamang yung Bmax, napalitan siya ng Mumax. Mumax is the maximum specific growth rate. Ito yun, Tapos yung C sub S, this is the same as the substrate concentration, the final substrate concentration. Yan yung lumalabas dun sa CSTR natin, dun sa chemostat natin. This is also the same as S, substrate concentration, generally in grams per liter. Tapos yung K sub S, as you can see, parang Michaelis-Menten constant lang siya. And this is the Monod constant. So as you can see, yung unit niya is the same as the substrate concentration. So ito yung Monod equation. Yung derivation nito, basically, kamukha din lamang siya ng Michaelis-Menten, hindi na lang natin uulitin. Parang, di ba tandaan niyo pa, we have two reactions or two equations. So, kung tandaan niyo pa yung ating yung substrate, kukumbine siya sa enzyme, tapos mapoform niya yung SE. Tapos yung SE, maghihiwalay siya, yung substrate magiging product plus yung enzyme. So parang ganun din to, siguro probably yung substrate, kakainin siya ng bacteria plus B. So magiging SB or BS, yun yung bacteria at saka substrate. Tapos yung BS na yun, ang product niyan is another bacteria. So magiging 2B siya, Tapos babalik na siya. Yun, parang ganun din lang. So you'll end up with this equation similar to your Michaelis-Menten equation. So what we're going to do is we need to show that this one is equal to D, D, remember D is itong dilution rate is equal to B over volume. Yung B, it's the same as your F, F kasi yung nakasulat natin dito, yung volumetric flow rate, F divided by B. So, I guess ito muna, muna natin, i-derive muna natin tong equation para mas confident kayong gamitin sa mga problem. So, I'm going to share a whiteboard. Okay. So, halimbawa, ito yung ating chemostat. Tapos we're maintaining a certain level of liquid. Ito yung ating agitator. So, initially, ang pumapasok dito ay F. Ang concentration ng bacteria or ng microorganism ay X sub 0. Ang concentration ng substrate ay S sub 0. So, paglabas dito, pag steady state, F pa rin yan. Tapos yung concentration na ng microorganism is X na, yung substrate natin S na. So halimbawa mag-aano tayo, cell balance. Cell balance means microorganism balance, So tandaan nyo pa naman, accumulation, basic equation sa sa chemical reaction engineering. Ibig sabihin ng accumulation, yung accumulation ng cell. Dito tapos this is equal to yung input minus yung output, this one. Tapos plus yung generation ng bacteria or ng microorganism, no? So pag steady state, ang mangyayari, when we have a steady state, ibig sabihin, pag steady state, accumulation is equals to 0. So mawawala lang to. Okay. Tapos, pag chemostat, so ito yung number 1 condition natin, steady state. Pag chemostat, yung input, kasi this is X sub O, usually pag chemostat, this is equal to 0, generally. So mawawala din tong input natin ng cell. Wala ring input ng cell. So 0 din to. So ito na lang dalawa yung matitira. So remember, ang ginagawa lang natin dito, yung output natin, negative, i-multiply lang natin yung flow rate, this is halimbawa liter per hour, times the concentration of the cell. No? So the concentration of the cell is X. You still remember this? So halimbawa to liter per hour, ito grams per liter. So basically grams per hour ng cell na lumalabas. Tapos yung generation. So ang generation natin, kung natatandaan nyo pa ang chemical reaction engineering nyo, this is simply RG, yung rate ng generation times yung volume. No? Kasi ang unit ng rate of generation is per liter, di ba? Baba, grams per hour per liter. Ganun yung unit na. Kaya may multiply nyo ng volume. Okay? So, let's define RG. Ang RG, yung rate ng generation, ay equal sa specific rate, mu. Wala. Sorry ha, may gumalaw. Nawala. Anyway, napakita ko na naman sa inyo yung I'm still recording. Napakita ko na naman sa inyo yung derivation and we are left with 0 is equals to negative output. Dito na tayo magsisimula. Can you still hear me, guys? Okay lang? Parang hindi ko alam kung anong nangyari. Basta nawala yung screen. Okay, let's continue. So nandito na tayo out minus output plus, kasi 0 yung accumulation, 0 din yung input. We are doing a cell balance, no? So times RG times B. O ganun lang yan. Tapos yung RG, I'm trying to define RG. So sabi ko nga sa inyo, specific growth rate lang yan times yung concentration ng X. So probably let's use X, no? Tandaan nyo pa naman to, rate of generation, RG is, let me define each of this. RG is the rate of generation of cell. Tapos yung ito, this is a specific growth rate. Tapos yung X, this is the concentration of the cell. So pag minultiply niyo yung specific growth rate tsaka yung concentration ng cell, as you can see, ang magiging unit niyan, lang naman to, dimensional analysis lang. Ang magiging unit niyan is grams per liter per hour. Di ba? So ayun yung explanation nitong equation na to. Dimensional analysis lang yan. Okay, so I hope you can accept this. So basically, papalitan nyo lamang yung mu using the Monod equation. Di ba the Monod equation is U max, no, times S divided by K sub S. This is the Monod constant plus S. Papalitan nyo lang yun. Tapos yung output, remember ang output natin is 0 is equals to negative flow rate times X, di ba? Tapos ito, RG, you have mu times X. So basically that's mu times X times B. So halimbawa, ililipat natin sa kabilang side yung Fx. Magiging positive na yan. Tapos you can cancel out B. X, di ba? Actually, dito pwede nyo na rin may cancel out kung Na-imagine nyo. So, if we're going to transfer, this is volume on the other side, this will give you F divided by B is equals to mu. Mu is mu max times S divided by K sub S plus S. Okay? So, ito yung ating working equation to solve the problem. Any question regarding the working equation? So, ang ginawa natin, nag-cell balance tayo to arrive at this working equation for chemostat. Chemostat is a CSTR biochemical reactor. Questions? Wala. So, yun, that's the reason why we are using this equation. F over B is equals to U max times S divided by K sub S plus S. So, let's try to use this equation in a problem. Let's go back to our PowerPoint. Okay. And then another concept is the cell yield, no? So, halimbawa, 'di ba, when using yung dinerive nating equation na mu max is mu is equals to D, no? Specific growth rate is equals to D. D is F over D. So, ang makukuha niyo dun is S or C sub S. So, halimbawa, ang tinatanong is what would be the concentration of the cell? So, in order to calculate the concentration of the cell, kailangan nyo pa ng isang data. So, ang tawag doon ay the cell yield, no? So, the cell yield is defined as C sub X, ito yung final concentration, ito yung usually yung kailangan nating hanapin. Tapos ito yung C sub X, parang halimbawa N-1, ba isang stage lang naman tayo. So, this is C sub 0. So, generally, this is equal to 0, pag chemostat. Okay? Usually given naman to sa problem. Given yan. Tapos itong C sub SO, this is initial concentration of the substrate. Yung C sub S naman, ito yung final concentration dun sa chemostat. No? So I hope you can imagine that you can use this data or given to calculate the final concentration of the cell. Ano lang naman yun. Ano? So, yung dalawang equation yung gagamitin natin. Ito, itong cell yield, at saka yung D is equals to mu. Okay, so let's try to solve this problem. Minimize na lang yung mga camera para mabasa niyo yung buo. So, suppose you have a microorganism that face the monod equation where mu max is equals to 0.7 R, K sub S is equals to 5 grams per liter. Okay, the cell yield is 0.65. You want to cultivate this microorganism in either one fermenter or two in series. The flow rate and the substrate concentration of the inlet stream should be 500 liters per hour and 85 grams per liter, okay, respectively. The substrate concentration of the outlet stream must be 5 grams per liter. So, if you use 1 CSTF, what should be the size of the fermenter? Okay, so basically, ang gagawin nyo lamang dito, yung first question, gagamitin nyo lamang yung i-derive nating equation, yung F over D, this is the flow rate, is equals to mu max times S divided by S plus K sub S. Sorry, dapat mauna to, pero parehas lang naman yan. Yung gagamitin nyo, lahat naman yan given. Ay, sorry, this is supposed to be B. This is supposed to be B. This is supposed to be B. Yan. Lahat naman yan given. Diba, may F tayo. F natin ito, 500 liters per hour. Tapos mu max natin, ito, 0.7. No? Tapos K sub S natin, ito, 5. So, substitute nyo lang yan. Tapos yung S is 5 grams per liter, no? And substitute nyo lang lahat yun. And then you're going to calculate B. Diba? So, ganun lamang yung first part. Yung second part naman, what is the cell concentration in the outlet stream? Gagamitin nyo lamang yung yield. Yung yield, cell yield, ano? Yung Y. So, Y is simply Cx. Kasi in-assume natin 0 na yung Cx. O ano? Cx tapos CSO minus Cs. So, ganun din dito. Meron tayong cell yield, ito. Tapos, meron din tayong CSO at saka CS. No? CSO natin ay ito, 85. Tapos ito yung CS. So, yun, makakalculate nyo rin yung CS. So, ganun lang yan. Ano? Let's solve this. So, substitute lang natin isa-isa. So, F is 500 liters per hour. Tapos, ito yung volume ng reactor, ng fermenter. Mu max is 0.7 per hour. Okay, confirm nyo na lang yung mga units na magka-cancel out naman. Medyo limited yung space ko. Tapos yung S natin is 5. Then 5. Yung KS natin is 5. Okay, so just try to get your calculator and you can now calculate the volume of the fermenter. 500 divided by X. Tapos 0.7 times 5 divided by 10. No? If solved, you're supposed to get 1,429 liters. So, ito yung sagot doon sa una. Ano? Okay, tapos dito naman tayo. Y. Can you still see this? Marunong na kayo mag-manipulate ng ano? I-ano nyo lang, ano? Minimize nyo lang. Kaya nga, merong chat. Yes, very good. Very good, Mariel. Ito, substitute 0.65 dun sa cell yield. This one. No? Tapos, C sub X yung hinahanap natin. Actually, meron pa yung C sub XO. Kaya lang, pag walang minention, ang default niyan 0. Ano? C sub SO is 85. Ito. Yun. Tapos, minus 5. Ano? Ito yung S. So, just calculate CX. So, 80 times 0.65. You should get something like 52. No? 52 grams per liter. So, ito yung sagot ko sa pangalawa. Questions? Do you have any questions? Madali lang naman, ano? So, sana makabawi na kayo ngayong midterm. Do you have any questions? Questions ba? Okay, very good, Mariel, 52. Okay, so, sa BBL, merong exercise. So, I guess, gawin niyo yung exercise sa BBL. Can you see the exercise sa BBL? So, try niyong i-solve yung problem sa BBL. Nakita niyo? Malapit ng matapos to. Ano? So ito yung sagot sa problem kanina. 1,429 liters tapos 52 grams per liter. So sa BBL paki-solve yung exercise sa BBL. Tapos magdi-disconnect ako dito kasi 40 minutes lang to Tapos mag-o-open ako ng bagong link. Connect na lang ulit kayo doon natin itutuloy yung discussion natin. Ano? So I'm going to give you 5 minutes to answer the BBL. Pero sa 25 pa naman yung deadline nun. Kung hindi nyo makuha ngayon, so okay lang naman. You can do an attempt. Tapos kung mali, you still have 2 more attempts. Ano? Hindi ko ba i-share yun? Subukan ko may share ko. Buksan nyo na, nakita nyo na yung ano, yung Chemostat exercise 1. So try to solve Chemostat exercise 1. So mahalaga kasi to ano, lumalabas to sa board exam. Ito yung lumalabas sa biochemical engineering. Yung monod equation. I'll try to answer. I'm going to give you 5 minutes to answer the simple problem. Tapos, again, I'm going to share the new link for Zoom. Saan ulit? Sa BBL ulit. Kasi I only have 7 more minutes. Hindi disconnect na to. So, end ko na lang para yung recording i-upload ko. Ano? Okay, so see you in the new link.